Thank you. Thank you. Wow, doesn't this title look like some kind of link bait or something? It does to me. So I'm Rob Tiffany. Yeah, I've done this IoT thing for probably too long. How many people in here have done an IoT project or been involved in that? There's a pretty good amount of people. Yeah, no shortage of hype. It's been going on for a long time. I'm just gonna, we got a short amount of time. I'm just gonna share some thoughts I have around what I've seen in IoT and what's working and what's not, and maybe how this community can help make it succeed better than it has. So here's where we got kicked off. I'm not gonna read this to you, but while I believe that IoT is really just an evolution of stuff, because I've been doing this since the 90s and it goes back further than that. A lot of the technologies you think of, connecting machines and sending telemetry and doing analytics, this goes back decades. This is really not anything new. It used different proprietary technologies. It didn't use IP networks, but the stuff was still around. It's just gotten a lot easier now. So if we go back a few years, though, we had this perfect storm, and I think it has to do with costs coming down that made IoT really explode, like it's a new thing or something. Lower costs on microcontrollers, on sensors, pervasive wireless connectivity everywhere, ubiquity, right? Storage prices are going to zero. Analytics that used to be the domain of the wealthiest companies or governments, well, now I can just go to apache.org and download them. Things like that. So, but what really got people going is this report from McKinsey a few years ago where they said the thing could be like an $11 trillion business. That is when the gold rush really started to take off. And everybody, that's why there's literally hundreds of IoT companies out there. They went flooding into their nearby VC and said, hey, McKinsey said this is gonna be an awesome market, give me some dinero. And so, and that's why you saw this gold rush. And so everybody and their dogs diving into IoT and they're cobbling stuff together the best way they could. Whether it's small companies, obviously all the big players, the hyperscale cloud providers, everybody jumped in. And I was a part of that too. I spent a lot of time at Microsoft and helped build Azure IoT. By the way, speaking of Microsoft, did you see the news this morning about them open sourcing their patent portfolio? That's pretty huge. Wow. Anyway, so there's all that stuff. I've seen other numbers, newer numbers keep coming out from different analyst groups or different surveys, saying in the next few years we're looking at maybe around 1.4 trillion per year for certain segments of IoT, 1.3 trillion maybe in manufacturing. Just to put that number in perspective, I mean, that number is really bigger than just about any other market you could be going after. 1.3 trillion, that's like 5x the whole machine learning, big data, AI space combined. So there's a lot of love out there for making things talk to each other, which is actually the easy part. This is a lot easier than the analytics, right? So how did we get here? I'll talk for a few minutes. Just for those of you who don't know a lot about IoT, I'll just give you kind of a background on what it is, where it came from. I've got a couple things going on here. Across the top, you can see the migration of the internet since the internet came out of DARPANET and made it public to everybody. And Tim Berners-Lee got the web going in the early 90s. And then on the bottom, I've kind of got this whole migration, these different industrial revolutions, which maybe you're wondering, why do I care about the industrial revolution? Well, it really all ties together. Like I said, the forerunner of IoT are these machine-to-machine systems and SCADA systems that all came from manufacturing, actually. And so this is a thing. And so now, while you could argue that the 90s, was it just content? Was it just static pages? Obviously, it turned into e-commerce. And clearly, I was involved in stuff that looked a whole lot like IoT back then. We had machines talking to each other. It was hard to do back then. It was primitive. Internet of People, that's when the rise of blogging, social media in the 2000s, and then of course now, IoT is exploding, getting machines talking to each other. The reason I bring up this whole industrial revolution evolution, government of Germany quite a few years ago talked about something called Industry 4.0 and really defined that. How are we going to take some of the concepts that we saw on the web, like mass customization? The internet allowed us through e-commerce. I want to go get a t-shirt and I can put any logo I want in any color and I could just do crazy customizations. How do you do that on a large manufacturing scale? How can you do that? If I'm making cars, how could I make every car individually customizable and everything while not screwing up the scale with which you get an assembly line. So a lot of folks have been focusing on that, and IoT is playing a big role in making Industry 4.0 happen. And you see other aspects in Japan. It's called Society 5.0, which I'm a big fan of. It should be people and machines. How can we use IoT technology to make lives better for people and the environment? So something to look at. Basic concepts. To keep it simple, IoT, we got publishers and subscribers. We got people talking and people listening, right? Publishers, when you think of, they're the machines that are talking. They're just giving you the internal state and sending it over some wire protocol, wireless. People in the past, people have been IoT devices by typing as fast as they can in keyboards or barcode scanning or things like that. And then you got subscribers on the other side. They're listening. Now sometimes they talk back, but mostly they're listening. So that's where you plug in things like advanced analytics, or if this then that, or deep learning, visualization on the web, automating processes, storing data, in historians, archiving, integrating with existing back-end systems, notifying, bots, acting on that stuff. I've often thought this whole thing looks a whole lot like Twitter to me. I wrote a paper on LinkedIn, I got totally flamed, where I just said that IoT is basically just Twitter. And I described why it is. I think it is. You got people tweeting, you got people following. I'm going to follow this guy, or I'm going to follow this collection of folks, and I'm going to aggregate that together. I think it's so important to try to keep simplicity at the heart of everything. That's really all IoT is. Don't conflate a lot of this hardcore AI and stuff you keep hearing with IoT. IoT is the movement of data around from knowing things, listening, and talking. Where you plug in a subscriber is where you could plug in something like deep learning. What I found, though, is there's a ton of value to be gained with the simplest stuff, actually. Just knowing. Here's some quick components of IoT. If you want to do your quick elevator pitch to someone, connect, collect, command, manage, analyze, act. It used to be shorter than that. Connect your machines, right? Connect all those things. Collect the data. What's command mean? It's a term called command and control. Basically, push a message back the other way towards the machine to update its configuration or its runtime behavior on the fly, if you can. People in factories won't let you do that typically. You don't actually get to talk directly to machines. You often connect to something called a PLC or other systems. Managing that data, manage identity, security, storage of the data. I don't know if has anyone ever heard the term digital twin? I spent a bunch of time doing that. Digital twin, that came from NASA, modeling a spacecraft digitally. Then everybody see Apollo 13, you got, Forrest Gump is up there in the spaceship having some trouble, and Lieutenant Dan is in Houston. Luckily, there's a mock-up down there to help him out. Well, you're not always gonna have that, so it's good to have digital twins to help you troubleshoot things. Analyze that data. We got no shortage of analytics tools now. You just need to know how to do it. And then you got to take action on those insights that you derive. If you don't take action, then what was the point? Here's some different deployment models. So a whole lot of people who are new to IoT, like the hyperscale cloud providers, when they jumped in, they thought, so if I kind of start at the left-hand side here, I think there was a belief that IoT somehow required the cloud, and that there was some utopian world where you would have trillions of IPv6 devices all talking to a cloud. And that didn't work out for a bunch of reasons, especially when I talk to manufacturers that still say the data doesn't leave my factory, or I'm not going to connect hospital life support systems to something that's on the internet. It just doesn't work out. Doesn't make sense. Or should I connect a fire compression system? So there's the one-to-many, which is probably good, maybe in outdoor scenarios, roaming around, that's fine. There's you've seen a lot of the cloud providers go, oh wow, maybe this edge thing is kind of important. So, well, let's push the cloud down to the edge. And so you're kind of seeing this coupled edge type thing that's maybe inside the four walls, connecting to things internally and kind of relaying that stuff to the cloud. You see my reality though, in the middle there, there's still lots of air-gapped systems, which I know may seem old school to you, but you got to do what the customer wants to do. You can't just drag them somewhere they don't want to be. The fastest way to get fired is telling someone who's got a nuclear power plant to connect it to the internet. That's stupid. Actually, most people should be disconnecting from the internet lately. What's the super edge? Fully making decisions on your own, not needing that whole connected thing. Autonomous cars. I know a lot of times people confuse connected cars with autonomous cars. All that intelligence has to be on board that car with an insane amount of storage, putting off terabytes of data per hour, maybe more, to make all that work with all the LiDAR and everything going on. So that's super edge. You see a globe privately distributed. This is stuff I've worked on in the past in manufacturing, stuff I've done with Hitachi. You got big customers, they have global footprint. They will not take a dependency on a public cloud, and but they still need to work with plants or facilities all over the globe. How do you do that? We used to do that before clouds came along. Like when we had to do it ourselves, and private networks and, all that kind of stuff. And then remotely controlled things, flying drones around farms, checking things out. So, and this is just probably scratching the surface. So there's no shortage of ways to deploy and make use of IoT. Oh, but there was a company in San Francisco, I know, called Helium. This was kind of their logo at, I don't know if it was at IoT World. There's no doubt that there's been a failure to launch with IoT. So we haven't quite hit that $11 trillion thing that everybody was hoping for, to ring the register on that deal. We're in POC hell right now. It's the land of proofs of concepts, not going to production, people. It's costing too much. There's so many issues. And I'm going to walk through some of these issues that are causing us to not have super success with IoT and talk about how we can solve that problem. So why is IoT failing us? Complexity. I've kind of talked about things. You've got machines, microcontrollers, sensors, weird data formats and strange wire protocols you've never heard of, hundreds of them. Wireless connectivity. It's not just cellular, it's not just Wi-Fi, it might be Zigbee, it might be Sigfox, it might be LoRaWAN, it might be stuff you've never even heard of. Capturing that stuff, is it on-prem, is it in the cloud? What the heck is a digital twin thing? Yeah, I got all this analytics for free from Apache. I don't know how to use them. It's not like there's just data scientists hanging around everywhere. And then integrating with the other systems. So a lot of complexity and I'd say a lot of what I'd call, I don't want to call them fringe technologies, but a lot of stuff that's super optimized, but not well known, not pervasively known, which is a problem. And so what do you have? You have a lack of skill sets. This is a common complaint. Oh, well, the IT department just didn't know how to put all this stuff together. It was too hard for them. Well, duh, there's too much stuff. We got to beat up on that. Projects taking too long. So when the things got kicked off, a whole lot of companies dove in, let's say the 2013 timeframe, said, yeah, we're going to make all this money, and they dove in, and they've already had like 2 different rounds of reorgs since then. Projects taking too long, customers, the manager that greenlit the project's already been fired because 3 years into the project, they're still nowhere. That's kind of a problem. Integration, not just integration with all these strange machines that hardly anybody in this room would even imagine to know how to talk to some of these things. But integration with existing back-end systems. You've got to integrate with the existing enterprise systems that businesses use. And so you see all you're doing is adding new silos. Poor data quality. This has to do with analytics. If anybody's a data scientist here, if you do machine learning, you know that data scientists end up spending 70 or 80% of their time not in R or Python, but in cleaning up the data because it's a wreck and it's a mess. And so remember, it's just garbage in, garbage out. Well, nothing's changed, right? And then security. We had that horrible, a few years ago, that horrible Mirai attack against all these IoT devices that were all using default passwords and created a botnet and did denial of service attack on DNS servers. So security, there's kind of a black eye there. So here's my idea to fix it. This is going to just seem really obvious to this crowd because you're immersed in this world. Other people I talk to go, oh, I never thought of this. Easy as the web is my mantra. I have lived with what I call the IoT snobs for years. I've worked with the smartest people in the world on this stuff and all the technologies that are the best technologies to use, the most efficient. But guess what? They're not pervasive technologies. They're not ubiquitous. They may be open standards, but to me, that's no longer good enough. It's more important for me for IoT and all the good it can do the world to succeed than to fail because we stuck with the best fringe technologies that are out there. This one's more efficient than that one. So let's embrace what the W3C has given us, because sometimes, I remember Scott McNeely saying this on stage at Java 1, like in 2001, as things were just crashing into the ocean after the failure of the dot-com era. He said something to the effect, well, it turns out good enough was good enough. And he's referring to Solaris versus Linux, right? And that's where I'm at now. Good enough is good enough, and we should go from there. So let's cobble this stuff together. I got less than 5 minutes. This is all going to seem obvious. Data transports. HTTP is good enough for me. Instead of just sticking with always having to use MQTT or AMQP, or there's zillions, BACnet, Modbus, all these kind of things, just use the transports we know. So let's just stick with REST for long-range LAN and WAN communications. Data formats. With as many wire protocols as there are, there's a zillion more data formats. Let's punt on that stuff, and we all know JSON. We love JSON. Let's stick with that. You know what? Heck, if anything I should be able to do in a web browser, name value pairs, even if I need to do XML, I should be able to work with that stuff, and that should be pervasive. Let's keep it easy, keep it familiarity, and having lots of people understand stuff is so much more important than maybe the best, most efficient protocol. How do we find data? URIs, right? I point to this URL to get data that I need. I point to that one to send data. It's how I cobble together and do discovery, how I build a highly distributed system instead of a lot of the proprietary systems that are out there. There are literally hundreds and hundreds of these IoT platforms, and you'd be amazed how they've been built. JavaScript. A whole lot of people know JavaScript. And I teach kids. I do the whole hour of code thing with code.org, and I teach kids in schools, with Elsa floating around doing a game and putting pieces together, and they're learning JavaScript. Use it. It's out there, it's pervasive, it follows, And so whether it's JerryScript on an embedded device instead of hoping people still know how to write C code, or Node, running on edge devices, on servers, doing business logic, doing filtering, doing rules, things like that. Let's use what we got. NPM, gosh, need I say more? It's a treasure trove. Everything you need to build your own IoT system is right there. Download, Restify, Express. Although, when I think of the messy part of IoT, it's right at the edge talking to these industrial machines. And you have no idea how to talk to them until you go to NPM and you go, oh, wow, there's a package for OPC UA. There's a package for Modbus. There's something from BACnet. I'm saved. Okay, I can talk to these weird things and then still use the technology that I love. Take care of the messy stuff out at the edge and then keep the rest of your system clean with pervasive technologies. Node-RED, wrap it all together, build these flows. Node-RED is a godsend. What an amazing technology. And some of my colleagues at Hitachi on our Lumada IoT system, been great contributors to the Node-RED project. I'm big fans of it. And so it's a great way to wire all this stuff together. Definitely one of the bright shining stars of the IoT movement. Security. Don't get hacked. Use TLS. Use security tokens. Use X509 certificates, stuff that we've been doing on the web. Make sure you rotate those keys, right? If you're putting credentials on a device, because usually you have a person who's logging in or whatever, but a device doesn't do that. Use the TPM chips, trusted platform modules. Store secrets, credentials in the hardware. Do that kind of stuff. Visualization, HTML5. We have no shortage of JavaScript frameworks to do charting, D3 and a million others, to visualize what's going on in the systems, which is a great thing. Command and control. So a lot of times we're thinking about sucking telemetry data from machines, but sometimes I need to talk back to them. I need to send a command. I need to update their configuration. I need to change the runtime behavior. Maybe I'm getting telemetry from a motor and it's getting too hot, and so I need to send a command to reduce the RPM from 10,000 RPM to maybe 5,000. That's what command and control is. I don't have to use things like MQTT or AMQP. I can use WebSockets to push that stuff down there. Heck, I should be using HTTP too. Full duplex, server push, it's more efficient. These are things that are all around us. Compression, we need to compress IoT data because there's a lot of these great networks that are narrowband, so just use gzip. And then where I want to finish is the world just doesn't need another frickin' protocol, okay? I'm so done. There are working groups today that are working on the one IoT protocol that's going to save the planet. We already have it. We already have what we need. We don't need any more working groups or committees. We've got what we need. And so anyway, hopefully this has inspired you to use the technology that's all around us to save IoT using the web. Thanks so much.